So I'm going to talk about the game process underscore C, which is the prologue wrapper process for this in this video. But the last one cut off, so I'm just going to talk about the revised public belief function. And I didn't really finish talking about this, but it's very simple. It just means that there's no chance anyone else can be holding a tile that's already been played. So we'll go to revised public belief. So all the revised public belief underscore played, passed, and hand functions call this. And all this does is this finds out for each player the number of known and unknown tiles, which is the certain and uncertain values. So anything that is a 0% or 100% chance or the player is actually holding is said to be a certain or a known tile. So it calculates the totals of both of those and then updates all the unknown tiles to be the percentage chance of the known over the unknown. So that's Bayesian inference there, and that's just called after every public belief revision to handle all the uncertain values. So I'll go over to game process C now. This one is the prologue wrapper. So this is called by the child process created in the server. That's the client in the server. When we want to talk to prologue, so all it's going to do, you got your int main here. So when we start it, it's given command line arguments from the server, which we talked about in the last video. So it compares the first command line argument to my string can play on end, which is just a string in the stringids.h header file that I've included in here, and in the server, which is just can underscore play underscore on underscore end, which is the name in prologue of the atom that we want to query. So we've set up three arguments here, which are just translated straight from the argv, the command line arguments given. So we have the end, the value of the chain we want to play on, tile left and tile right. So it's the two ends of the tile we're trying to play. We find atom, so this is can't play on end. So we're finding the unique prologue ID of this atom here inside the prologue file. Then we just go result equals can play on end wrapper, and we pass in those arguments that we established right here. So what this does is up here we have, first of all, it's just going to handle if it's an invalid request, it's just going to return false and say you can't do that. So then we begin prologue query, we set the arity to 3. We create an array of prologue terms, PL terms, with size 3, which should just be the arity there. And then we just go prologue arg0 equals make integer. So this is converting it to a prologue term. And we just do that for each of our arguments that we've passed in there. We say number of solutions equals 0, which we're going to update in a minute. This is the array here that holds the solutions we get. And we say res equals PL query call. We pass in the func, which again is from the first function of the int main, where we set up the func equal to the unique prologue ID of the atom can play on end. We pass in the arity, so which is prologue's name for the number of arguments. We pass in the prologue arg array, which is the PL terms that we created from our arguments of the function and from the parameters. We handle exceptions here, so if it's equal to PL underscore exception, which is just 2, so if it's 0, it's false, if it's 1, it's true, if it's 2, it's an exception. So we just throw that error if we get one. And then while there is a solution, we throw that into the solution array here. So we just say it's true if we get a response that is true. And then we go res equals PL query next solution. So PL query ends, so we just close the query and then we stop prologue, and then we say if there's 0 solutions, we return false. If solution 0, which is just the first solution, is equal to 1, because there's only one solution returned by my prologue call, we return true, or we return false if it's not true. So pretty simple there. And that's pretty much it for the prologue wrapper. We have this function too, start prologue wrapper, so it's just super simple stuff there. This is just the template for what this is here. That's pretty much it for this file. Obviously, we've got some includes here, a header file for the can play on end atom, and then the string IDs I talked about a minute ago. So I can probably fit the player client stuff in this video, so I'll just pop over there now and we'll go through that. So we'll start down in the int main. So this is where pretty much everything happens for the player client because it's all running in a loop. So we set up our arguments here. I've just got a few options that you can do, smart mode and the verbose output. We set up the node title for the process, and then we do some clients here for all the services that we established in the server. So player turn ping, can play ping, play move, player hand, and chance holding. So we've talked about all those from the server. So what we're going to do first, we're going to query the service for player hand, which we're going to get back all the tiles to put in our hand. We're going to update our hand. We're going to say we join the game as player ID. Then we're going to go and just print out the tiles in the hand. And so the main loop's where most of it happens. I've added a move delay just so it's easier to see what's actually happening when the player's taking their turn and looking at all the decisions and stuff. So we set up the service, the ROS server service thing for the turn. Then we go, I'm this player, and then we call it. So we handle an error on it, but if there's no error, we go current turn equals serve.response whose turn. So that's saying that that's whose turn it is right now, and then we update the chain values as well. And then so we say if current turn is equal to this player's ID, so if it's my turn, now we can find a tile to play. So what we do first, we clear the options. So this is just a super simple function that iterates over the play options matrix that I created and sets all the values to -1 so that we know there's no play options right now, or it clears all the play options from the last round or the last turn. And so we're looking for playable tiles. We query or we invoke the search hand function, which is a recursive function that looks through the hand of the player. So we pass in all the services and then a 0. So the 0 is the index of the place in hand. So if we just scroll up here to that's the clear options there as well, very simple. Search hand, so that's all our services and clients there. Then int I is our index in hand. So you say if hand I, left side is greater than -1 and right side is greater than -1. So if we have a tile at this index in hand, then we're going to ask the server if we can play it through this service here. So we find out where we can play it. If it's -1, we know we can't play it. If it's anything else, we know there's somewhere that we can play it. So if it's 0 or 2, it means it can be played on the left side or the low side of the chain. And if it's 1 or 2, it can be played on the right side. So 2 again means that it can be played on either side of the chain. So all this here is if for task 2, if we're enabling smart play. So for that, I'll talk about that in a sec, but basically you have the default value 700. We initialize a play option here. So this is on the, so we set the value there, and then we say it's playable on the low chain. So this options here, this is the index in hand, this is the side of the chain. 0 here means that it's 1 for playable, and then the 1 is the actual value of playing it. So that's pretty simple there. And then we've got, so for the actual enabling smart play, so first of all what we do is we add, this is a very low weighted factor, but we increase the value by the sum of pips of the tile. So this is just to encourage the player to play their highest pip sum tiles first so that they can minimize the amount of pips in hand at the end of the match, at the end of the round. So we send a request, and this is about the holding chance stuff. So this is where it gets a little bit more juicy. The target ID is going to be the next player in the chain, and then we say, that's our target. So n is going to be the value of the tile, or it would be the new chain, the value of the end of the new chain we would create, if that makes sense, by playing this tile. So we check if other players are going to have, or the next player in the chain is going to have a good play or a play for the chain we would create by playing this tile, and that's how we determine the cost there. So we just increase the value. So for this one, we reduce the value by the chance cost, which is just the sum from the previous thing of from the previous video in the server the sum of all the chances of them having a tile they could play on the new chain we would create. Then what we do is we send in would cover, which is the piece of the chain, the end of the chain that we would cover if we were to play this tile. So it gets a bit confusing here. I'm sorry, I'm stuttering a little bit. So this is basically saying if we cover up this end of the chain, is that going to make it more difficult for the next player to make their turn? So we increase the value by the chance that the next player has bad play, I guess, what you would say. So after that, it's the same thing for this one. So it's just the other side. So for our right side of the chain, so that's all pretty simple there. And then we sleep for the search delay. So again, that's just searching through the hand, it's delayed so you can see what's happening. And then if we're not at the maximum size of the hand, then we just recur. So just a recursive function there. So after we've done that, we've iterated over that 7 times, and it just has a return value. So if the service queries fail, then we would actually exit the program, because that shouldn't ever happen. So after that, we do the service move. So we are basically here just looking for the best tile we can play based on our options. So we have now, for each tile in hand, we know whether we can play it on the left or right side of the low or high end of the playing chain, and we know the value of playing on either side of the playing chain if we can play it. So first of all, we just initialize everything to -1. Then we go over all the tiles in hand. So if there's at least one tile left, we say any tiles left is 1. So that's how we know that we've emptied our hand, if that is 0 at the end of this for loop. So we check each option for each tile. So playing it on the left or right side of the chain, low or high end of the chain. And if any cards were unplayable, then we just say, or any cards were playable, sorry, then we send that to the server. So if best index is greater than -1, then we're going to play whatever the best end to play it is on. We can send that back to the server with all the information they need. And then if no tiles are left, then the chain end equals -2, which means that the game's over because this player has emptied their entire hand. And then if everything remains at -1, not -2, then that means the player's passing their turn because they have nothing to play this turn. Can't play anything on the current chain. Then we just send that back to the server, and this repeats constantly while ROS is okay. So that's the client there and the game process, and that should be pretty much everything. Obviously you have stuff up here like your hand, your imports, the delays, the chain, the options, matrix, all that kind of stuff, but it's all pretty self-explanatory. These are just like utility functions. Other than that, I think that's everything. So thanks for watching.